Quick lesson today. This is called critical numbers. Section 3.1 in the book. And a critical number, by definition, is just where the derivative equals 0 or is undefined, and it's an x value. These critical numbers must be defined in the function as well. And we'll talk about the third example I do, we're going to see that. So basically, though, we're looking to see where the first derivative is 0 or undefined. So, a very simple example first, find the critical numbers of this function. So we need to find out the first derivative. That's 4x cubed minus 12x squared, and we need to find out what that equals 0. To solve this, the easiest way to do it is factor it. There's a 4x squared common. You're left with x minus 3, which means the derivative equals 0 at x equals 0 and x equals 3. That's it. Those are the critical numbers. You always want to check to make sure they're defined in the original function, and they are. It's always nice to check on a calculator, and here's how you would check. Since the critical numbers happen where the derivative is 0 or undefined, a derivative is 0 when it has a horizontal and tangent line. So if you look at this graph, the tangent line would be horizontal right here. Right here. X equals 0. And also right here, which is x equals 3. So that's the first example. Pretty easy. Second example is a function. It's actually a radical function. This is the cube root of x squared. So to find the critical numbers, we're going to set this equal to 0, set the derivative equal to 0. So the derivative is 2/3 x to the negative 1/3, and the derivative of 3 is 0, so plus 0. So your derivative is 2 over 3x to the 1/3. So the critical numbers are where the derivative is 0 or undefined. It's 0 where the top equals 0, but that can't happen. 2 doesn't equal 0. It's undefined where the bottom equals 0. So x to the 1/3 equals 0 when x equals 0. Determine if that's defined in the original function. In other words, can you plug in 0 to this function? And the answer is, of course you can. Just be 3. So x equals 0 is a critical number. So this is an example where the critical number made the function, the derivative undefined. And just like the last one, you're going to look at the graph just to make sure it makes sense. And you see that this graph, and I'm graphing the original function here, you see that this graph at 0 comes out to a corner like this. So that is an undefined derivative, so it makes sense that the critical number is at x equals 0. So those are the first two examples. I'm going to stop here and make a separate video on the last example because it's a little bit longer. So, and make sure you do view that video because there's going to be a couple of things that happen.